Hello again. So last time we discussed how to solve different circuits by using the node voltage method. From today onwards we are going to start another method which is called a mesh current method. So here in this question we are given a circuit in which we have to find out the value of V0 by using the mesh current method. So in order to find all the values by using the mesh current method, we have to select different meshes in our circuit. Mesh is basically a closed path in a circuit, and after selecting the meshes we have to suppose any current in that mesh. So here we have basically three meshes, 1, 2 and 3. So let us call this one mesh number 1, this is 2 and this is 3. So after describing them as mesh, so let me use different colors for each mesh. So for mesh number 1 I'm using the red color, and I am supposing that the current of I1 is flowing through this mesh which is in clockwise direction. Okay, similarly in mesh number 2 I am supposing that the current here is basically the I2, and in mesh number 3 the current here is I3. okay, and the direction of all the three currents are in clockwise direction. Here we also have a dependent source here in mesh number 2, and the value of the voltage of this dependent source basically depends upon the current I5 which is flowing in mesh I1. So this is literally the current I1 here. I5 is equal to I1. So let me write here first that the value of I5 is equal to the I1. okay, so this is our first supposition, or I can call it, this is not basically the supposition but this is the statement which has been given here. okay, so now let us start our question by using the mesh 1 here. So in mesh 1 let us apply KVL. okay, so by applying KVL we can see that here we have this and these three elements here. One is the voltage source and the two are the passive elements. So in order to find, or in order to apply the KVL here, first here the current is entering through the negative node, negative terminal, and coming out of this positive terminal. So this is basically the voltage rise. So writing it here at the left side, 25 is equal to, and we can see that this is the passive element. So across the passive element we also observe we always observe the voltage drop. okay, so the 25 is equal to V6 plus V8. okay, so this is the equation for this mesh. Similarly the equation for mesh 2 here. okay, so again applying KVL in mesh 2, we can see here that this and this, in across all the three we have the voltage drop here. So applying KVL here, V8 plus V8 plus 5I5, this is equal to 0. And in mesh number 3, again applying KVL, here we can see that in mesh number 3 we have these three elements which are again passive elements. So here in mesh number 3, V6 plus V8 plus V2 equal to 0. okay, so these are our three equations. So and let me separate them out. okay, and these are our three equations. Now let me solve them one by one. So in mesh number 1, what is the value of v6? V6 is basically the value of the the value of the resistor multiplied by the current passing through it by the Ohm's law. So the current through it is basically I1 minus I3, which is the sum difference of the currents which are flowing through this resistance. So now here it will become 25 is equal to the 6 I1 minus I3, and similarly V6 is equal to V8 is equal to the 8, and the difference of the currents in these two meshes, so 8 I1 minus I2, these are two currents. So rearranging them, okay, and writing them here, 6 I1 minus 6 I3, similarly plus 8 I1 minus 8 I2 is equal to 25. So these two terms will be added together, and I will get the 14 I1 minus 8 I2 and minus 6 I3. This is equal to 25, and let me call it equation number 1. Okay, so this is my equation number 1, which is the equation of mesh number 1. Now proceeding towards the mesh number 2, here we can see that the value of the voltage across this resistor, we called it V8. So the value of this voltage is again the value of the resistance multiplied by the difference of the currents in these two meshes plus 8, which is the voltage across this 8 ohm. Now the currents which are flowing through this one are I2 and I3, and the difference between them is I2 minus I3, and similarly the value of 5, and we know that from this equation here that the value of I5 is equal to the I1. So let me write it here, it will be I1, so it is 0. So now again solving them, 8 I2 minus 8 I1 plus 8 I2 minus 8 I3 plus 5 I1, this is equal to 0. Okay, rearranging them, and I will get the minus 3 I1. Okay, and then adding these two terms together, 16 I2 and then minus 8 I3, this is equal to 0, and let me call it equation number 2, and again selecting it. Okay, so this is my equation number 3. Now let me proceed towards the mesh number 3. Okay, in mesh number 3 we have all the three resistors here. So this is basically the 6 ohm resistor, and the currents to it are again I1 and I3. So 6 multiplied by I3 multiplied by I1. So please note one thing here, that when we are in this mesh we used I3 minus I1. Okay, we took the current in that mesh as positive and the current in the other mesh as negative. Okay, you can see here that the value of I3 is positive and the value of I1 is negative, while when we were in our mesh number 1 we took the value of I1 as positive and the value of I3 as negative. Okay, so whenever you are in any mesh you have to take the current in that mesh equal to basically you have to take that current positive. Okay, and the other current which it is sharing with so you have to take that current as negative. So this is the essence of this technique. Okay, so now let me write the equation for this one, and that would be 8 multiplied by I3 minus I2. Okay, and plus what is the value of V2? The value of V2 is basically 2I3, and this is equal to 0. Let me simplify it again, 6 I3 minus 6 I1 plus 8 I3 minus 8 I2 plus 2 I3 this is equal to 0, and now rearranging them, we will get the minus 6i1 and minus 8i2, and now adding the terms which are related to i3. These are the three terms, and adding them together we will get 16i3 equal to 0. Okay, so this is the equation, and let me call it equation number 3. Now as we have all these three equations in which the three are unknown, three elements are unknown, which are i1, i2 and i3, and similarly we have three equation for finding the solution of our unknown quantities. So you can use any method, whatever you like, to find the solution of this system of equations. This is basically the system of linear equations. So you can use any method, and by using any method of finding the solution of these three equations, we can get the value of i1 when you will solve it by using the Wolfram alpha, or by using any calculation method, Gauss elimination method, or the Cramer's rule, or any other method, by using matrices or the equation method, you will get the value of i1 equal to the 4 amperes, i2 equal to the 2 amps, and i3 equal to the 2.5 amps. Okay, so these are basically the three values which you will find out by solving these equations. I am not solving these equations for you because this is a linear algebra and you can easily solve this, but to generate or to formulate the equations is a major part in circuit analysis, and I have done it for you. Okay, so now after it, in the question statement, what we have to find out? We have to find out the value of v naught, and we can see here that the value of v naught is basically equal to the 8i1 minus i2. Okay, so this is the equation of v naught. So let me put values here. So this would become 8, and the value of i1 is 4 minus 2, and v2 8 multiplied by 2, v naught equal to the 16 volts. Okay, so this is the required answer of this question, and 16 is the voltage value of this v naught value. Okay, so this is the end of this assessment problem 4.9. I hope you have found you will find out this very useful in solving other related questions which relates the current controlled dependent voltage sources, and finding the solution of the circuits by using the mesh current method. So I think it's enough for today, and I will see you in next class. Thank you so much.